التشرف بدعوة المدير العام من شركة Analytical Graphics. With pleasure, I would like to introduce our next speaker, Diogo Rodrigues, General Manager of LastTech Consulting and AGI Middle East, who will give us a presentation about GIS modeling and simulation techniques for better defense and intelligence and security.
Thank you for the kind introduction. So this is the theme of my talk today. But before I introduce the theme, I'd like to talk a little bit about our motivation in doing so. And our motivation is that in an increasingly congested, sorry? Sure, I'll try to make it very quick so you can go to lunch. So we're living in an increasingly congested, competitive, and contested world. And as such, it's of paramount importance to be fully aware of your surroundings and be prepared for all possible scenarios. And we feel that being aware of our surroundings is impossible without GIS information, and being prepared for all possible scenarios is impossible without simulation. And also, you need to be able to model all kinds of movement of assets and entities out there, I think. So just to give you a little bit of background information, back in World War II, we had GIS was basically situational war or situational, where you had people moving sticks on a map and trying to receive the latest updated information and position the assets. Now we've came a long way, and with the computer age, now we have moving map displays that show the latest position of any kind of assets. But still, there's still a lot that we can advance on top of this. And to this day and age, this is still the case in many defense organizations worldwide. Nevertheless, with the convergence of technologies, with high data rates, with fast processors, 3D and GIS capability, nothing stops us from from processing wide amounts of geospatial data coming from all different kinds of sources, SIGINT, MASINT, IMINT, and GeoINT, and producing rich 3D environment that allows for the operators, for the decision makers, to really analyze all their surroundings and really be prepared for everything that is coming their way. So that's what we do with AGI. We specialize in software solutions for space defense and intelligence, and at LastTech Consulting, we bring solutions from AGI and its technology partners together in order to provide specialized solutions for space defense and intelligence. So here you can see some of the results of some of those simulations, but this is possible nowadays with today's day and age technology. Now, the outline of my presentation, I'd like to talk about GIS and modeling and simulation for defense, security, and intelligence. Talk a little bit about some of the specific application areas in defense, security, intelligence. Talk about some examples across the program lifecycle. So, in research and development, testing and evaluation of systems and platforms, applicability in terms of training, also operations, and also some final remarks. So, but first, you might be all aware of GIS information, GIS systems, but you might not be so familiar with modeling and simulation. So I'd like to start out with the definition of modeling and simulation. We understand the working definition as the ability to replicate existing and future systems and embody their behavior in order to gain insight into how they will perform in their operational environment. And their operational environment is very critical because it can only be described with a rich GIS environment. It is also of paramount importance for you to think about what are the answers you want to get out of simulation. You want to retrieve what's the optimum specs for your system. You want to understand the human factors of the human-machine interface. You want to test out your procedures. You want to test out your tactics for using procedures. Depending on your objectives, you need to come up with solutions. And some key factors are the level of detail of your simulation, you need high-level assets, or you can go with, you need to model high-level assets, you need to model components. Do you need to introduce randomness in order to add more realism to your simulations? Do you need to run it in real time with humans in the loop, or can you afford to do it faster than real time? What's the simulation engine? Is it going to be centralized, or is it going to be distributed? And do you need artificial intelligence to play the red forces, for instance? And also the level of automation and the level of GIS, geospatial content, which more often than not can be geotypical instead of geospecific. Now, in terms of applicability, it's applicable throughout the entire program lifecycle, as I just mentioned, right up to you and trying to understand what exact systems you need. Instead of going for catalog-based purchasing, you can really go and address your, through modeling and simulation and GIS, you can address your shortfalls and see what's the best way to go forward, which kind of system really gives you the best operational delta. Up to development and test and evaluation, GIS provides a very good reference, and most of these platforms are trying to make measurements or trying to attack certain locations, and GIS provides a great baseline reference. Into this, into training, so producing very rich and realistic training scenarios for your operators, so that they're well versed in all kinds of scenarios that they'll be encountering in real life, and also operations and data exploitation. So going into mission, things like optimum mission planning, mission rehearsal and optimization, command and control, situational awareness, after action reviews, throughout data exploitation. So at LastTech, we work with different range of partners, AGI being one of them, but also different companies that provide different pieces to produce bespoke simulation capabilities. You're probably familiar with that, the GIS world, but in the modeling and simulation world, the industry is very fragmented, so you need to work with different kind of players. So just providing you a quick example of a sample GIS to model the same workflow. So you have your information loaded in a GIS database, which typically most of the time is 2D. And from that information, you can extrude building information and produce at least a geotypical environment that you can use to test your UAVs or whatever kind of platforms or whatever kind of simulation that you need to run on. And more often than not, this is enough in order to reproduce your 3D environment. You don't necessarily need to go to the extra levels to really have the buildings look exactly like they are. They just need to be most of them not just geotypical. Now, talking a little bit about the defense areas. Here you can see multiple airborne platforms being simulated within our technology. We can simulate all kinds of engagements, land, air, sea, and space. And we built the environment up from the GIS information. So you can put airspaces, you can correlate the video that the UAV is making, you can put the surface-to-air missile engagement ranges, and you can really simulate all these things ahead of time so that you're very well prepared for what's to come. Also in terms of air defense, so simulate the radiation propagation of the radars, their operational modes, modeling how they can react against multiple kinds of threats. Here we're simulating some fast jets, but you can simulate UAVs, simulate the radar cross-section, and really see how good your air defense system is against a whole solution space of threats. Same thing goes for maritime. So you can simulate different kinds of maritime scenarios, and different kinds of environments, and you can have almost like a very realistic level simulation that really reproduces the environment that you encounter in naval operations. Same thing applies for the Army as well. So you can with nowadays technology, can simulate all the physics sides, all the human interactions. So there's no excuse not to be prepared. Same thing applies for special forces, that more often than not, they need to go into new engagement zones, and they need to quickly prepare for them. So GIS provides them a quick way to immediately to rehearse what they're going to do, and be able to do some quick analysis to see what's the best path that they should take in order to neutralize a certain type of threat, and do like very quick mission briefing. Same thing applies for security. So in the line of security, some major factors are area of interest, how well will a certain area be covered, will be operating day and night, fusing data from multiple sensors, so video cameras, RF direction finders, any kind. Is it going to be indoor, outdoor? How much persistence do you need to execute on a certain area? If you have UAVs, do you need to simulate pattern of life in order to being able to put together the full picture? Also, another thing that is characteristic is there's a lot of in security. There's a lot of inactivity, and the operators need to be ready when something happens. And usually, they have very little time to react. So, modeling and simulation can provide them a very quick way and effective to allow them to be ready for what's out there. If not enough things are happening in real life, you can make sure that they're in their simulated life. There's a mouthful of them. And also there's evolving threats. So we can see the trends nowadays that the threats are trying to mimic nominal behavior, and out of a sudden they pose a threat. So it's very important that you can analyze patterns of life and run automated analysis. So just giving you an example of how sophisticated these simulations can evolve. Here we can see we're simulating a normal pattern of life, all being controlled by artificial intelligence. You can see a child crossing the street here. And so you can create very rich environments that people, that are typically what usually your cameras are looking at. Here we can see the same case applied to a road. So we're simulating day and night operations, we're simulating day and night traffic, and here we're simulating some passengers going into a subway. Here we're actually simulating a subway emergency. But because we were able to simulate all of this, then the next step would be to connect all of this into a command and control system and provide a very virtualized environment for you to train your operators on. And moving into intelligence, so we can simulate all kinds of intelligence collection, satellites, from UAVs, aircrafts, all kinds of payloads, electro-optical infrared, SIGINT, direction finders, full motion video. And we can correlate that with the previously acquired GIS information. This allows for a number of automated processes to run on top of it. So you can geo-index it, you can put human information on it, and it becomes a lot more discovery. So your archives you can bring life to your old archives, and you can do full forensic analysis on top of it. Here we're showing some examples under which we're correlating GIS video data from a UAV, multiple flights, and we're correlating with a GIS database. So in this screen, you're going to see a live video feed coming from a UAV, and then here you're going to see the simulated feed from the UAV from the same collection area. And this is perfect for change detection, because you can really see things, how they look like from the same acquisition. So moving on to the augmented reality, you can now fuse real data with GIS data in real time. So you can take raster data with full motion video and apply it to your moving map display. And you can simulate the view from the camera sensor, which makes the operator life much easier because he can quickly understand that this is a road. He can annotate things that are of interest to him, and immediately all this data becomes referenced and searchable through the archives. You can now go back to the archive and say, well, out of all my other missions, how many times did I acquire this target non-intentional? So this brings me to my final remarks that I would like to make, was that modeling and simulation is a very natural extension for GIS. And we've seen the evolution of GIS technology going that way. Latest versions of GIS solutions include 3D capability and include the ability to add temporal data. So we consider modeling and simulation the next step toward of GIS. Also, GIS data is becoming dynamic, multilateral, and multi-sourced and multi-format. And typically, the modeling and simulation community has had a lot of experience in interfacing with all kinds of visual terrain databases that were always 3D. So, cooperation with, if the GIS community is willing to cooperate with the modeling and sim community, a lot of benefits can be drawn. Also, we believe the GIS organizations, they need to differentiate themselves by offering value-added services to intelligence, defense, and security. GIS data, according to our view, needs to be turned from data into knowledge. And it's the value-added services and the ability to produce results on top of your GIS data that will produce that knowledge. And we also believe that armed forces need more than GIS to stay ahead. You need to model all kinds of activities on top of your GIS infrastructure. You need to move from catalog to needs-based procurement. You need to be procuring cost-effective training. And we need to be running efficient operations in today's day and age. With that, I'd like to open up for questions.